Hello my dear students. Well, in today's video we'll discuss about the filling of the orbitals in an atom. We have already discussed the Aufbau principle, and you know that in this principle we can express how the electron can be filled in an atom. In this video, first of all we'll talk about the n plus L rule. The very next one, that is the Pauli's exclusion theory, and in the last, that has been Hund's rule of maximum multiplicity. So here we are. So we have n plus L rule first. Well, as per this rule, we can say that we have to fill the electron in that energy level, or you can say that in that orbital which is having the least value of n plus L. If we just talk about the n plus L rule, we can consider this particular series with respect to Aufbau principle. We can say 1s, 2s, 2p, it's 3s, 3p, then comes what? It's 4s, and then comes it's 3d. Alright, so this is as per Aufbau principle. Now we can say that what is the n plus L rule here? I'm just putting the value of n here, and here is L value, and we can go for n plus L like this. If we talk about in this particular orbital, we have the n value 1, and you know that what exactly the value of s, that will be 0, so it will be overall count, it's 1. When we consider 2s, then the n value is 2. Obviously s is 0, right? So it will be 2. As far as this 2p is concerned, we can say that the n value is 2, and where the p orbital is there, that means the L value comes 1. So obviously it will be 3. Let's see in 3s. So it will be the n value is 3, and you know that s is here, so it will be 0. So overall it will be 3. In case of 3p, we have the n value 3, p it's 1, it's overall n plus L 4. Let's see in 4s, the n value is 4, L value, that will be 0, so it comes 4. And in the last one, you can say the 3d, the n value is 3, and you know that the d orbitals we have, so L value will be what? It's 2, so it comes 5. Here you can say that electron has to fill in first s orbital, right? Then the electron comes in 2s, because the n plus L value for 1s is 1, which is lesser, right? So electron enter in first s firstly, right? Then comes in the next one, that will be what? 2s, obviously. When we consider these two, you can say n plus L value, because in 2p and 3s they are what? 3 3, where the electron comes first. So as per n plus L rule, we can consider if the value is same, then the electron comes in that particular orbital which has the less value of n. So obviously in 2p, the electron comes first in comparison to what? It's 3s. Well, you see in case of 3p and 4s, right? So electron comes in which orbital? Obviously in 3p, because the value of n plus L both have same, that means the 4 value is coming. So basically the electron enters in 3p first, right? Because the n value is lesser in 3p in comparison to 4s. So this is the basically order where we can say that the electron has to be filled in that orbital where the n plus L value will be less. So this is the n plus L rule. Now we move on to the next principle, that is the Pauli's exclusion principle or Pauli's exclusion theory. So we have the next theory, that is the Pauli's exclusion theory or Pauli's exclusion principle. Well, we can say with respect to this theory or principle, an orbital can have maximum 2 electrons, and these must have opposite what spin. So basically this is the theory, and we can consider here all the 4 quantum numbers, right? So if we consider 2 electrons of the same atom, right? If we consider 2 electrons of the same atom, right, then all the quantum numbers, all right, all the quantum number, that means we can detect the value of n, L, M and S, right? So maybe possible that all the 3, you can say, the quantum numbers are same, but there is the variation in the quantum number what S, that means the magnetic quantum number, spin quantum number, that will be quite different. If we consider 2 electrons of the same atom, then the all quantum numbers, that the all 4 quantum number values should not be same, right? If we consider n, L, M value, there is the kind of, you can say, similarity, but there is a difference in the S value. So it will be what, plus half or minus half, right? So this is the Pauli's exclusion theory. We can explain with this an example. Let's see. We have the one atom of you can say any atom, right, which is having 2 electrons. So I'm just explaining the Pauli's exclusion theory with this example. I have suppose 2s, right, 1, and another electron we have 3, suppose s1, right? So I'm just mentioning here the value of n, L, M and S. Clear? In this manner, here is n, L, M and S values. Obviously it will be different. Well, you see that what is the value of n? Here is 2 and here it comes 3. As far as L is concerned, so it will be what? It's n minus 1, obviously it's 0. So it will be 0 as well, because we are taking what, s orbital here, and if we just detect the value of what, m, then it will be 2l plus 1. So it will be, yes, it's 1 and it's 1. But as soon as we see that in 2s1, the 1 electron is here and 1 electron is here, both s orbital consisting single electrons. If we just consider the 3s and 2s orbitals, s orbitals, these are the orbitals, and it consisting 1 electron, so the movement of the electron is in a single direction. All right, that means it is showing the positive direction. That means the plus half we can consider for this one, and plus half consider for this one as well. So s value will be what, plus half, and here is plus half. So we can say that the Pauli's exclusion theory, the all quantum numbers for 2 electrons of the same atom should not be equal, right? There is some kind of possibility that there is the difference in these quantum numbers n, l, m and s value. And very important thing, which is I think you can understand that each and every orbital, right, consists two electrons, and two electrons must have the opposite spin, right? So this will be the existing, you can say, orbital. All right, this will be the correct one. So this is the Pauli's exclusion theory. So in the last we have the Hund's rule of maximum multiplicity. It's a very important law, and it will definitely help in chapter number 3rd as well as in class 12th as well. Well, let's see that what is the statement of this particular rule. Well, electron pairing in the orbitals cannot occur until each orbital of a given subshell contains one electron each or is singly occupied. So this will be the statement of Hund's rule. It means we can fill the electron in p orbitals or d orbitals or f orbitals, p, d or f orbitals, right? So basically if we talk about the p orbital, so we know that the p orbitals are px, py and pz, right, in this manner. Suppose these orbitals, it's suppose 3p1, right? So first of all, electron must be enter in this first orbital, so we can fill the electron like this. But if we consider 3p2, then it should not be this. Well, let's see that it should not be this. That means if we just fill like this, that means it's wrong. All right, so which will be the correct filling? So first of all, electron has to be entered in the first orbital like this, and the very next electron has to become in next orbital. So this will be the right way to fill the electron, right? Well, if we have 3p3 orbitals, or sorry, 3p3, you can say a set of quantum number, then 3 electrons are there. So electron has to be filled in this orbital, then comes the second electron in the next one, and the third one is here. This is the half-filled condition, right? We know that the half-filled condition are also very stable, right? So if we fill the electrons in 3p3, so we can enter one electron in each orbital first, right? Well, let's see that if we have 3p4, then how to fill the orbitals. So first of all, we have the 4 electrons. First of all, electron comes in the first one, next in next, and the third one in the third orbital. Now we have the 4th electron. Then you can go for what? Yes, pairing like this. All right, if we consider 3p5, then it will be filled like this. So 1, 2, 3, 4, and the 5th electron comes in the next one like this. And finally we have 3p6, suppose, right? Then the electron can be filled like this: 1, 2, 3, 4, 5, and 6. So pairing has to be done after filling electrons in each and every orbital, right? So this is the Hund's rule of maximum multiplicity. Thank you very much.